Now see, I am coming to some examples of NCERT book. In my book this is given as problem 2.6, but you are using the new book, that is 2019-20 book, because I am using those pages only. In this recording you can see, calculate energy of 1 mole of photon of radiations whose frequency is 5 into 10 raised to power 14 hertz. Coming to the solution, students, we know that energy of 1 photon is given by the expression E equals to h nu. So h equals to 6.626 into 10 raised to power minus 34 joule second, which is Planck's constant. H I told you, nu equals to 5 into 10 raised to power 14 per second, which is given in the question. E equals to h nu, hence you can substitute the value of h and nu. It comes out to be 3.313 into 10 raised to power minus 19 joule. So energy of 1 mole of photon, students, this energy is for 1 photon. So for 1 mole you need to multiply with the Avogadro's number, you will get the answer. Now I am coming to problem 2.7. A 100-watt bulb emits monochromatic light of wavelength 400 nanometer. Calculate the number of photons emitted per second by the bulb. You know that power of the bulb given is 100 watt. 100 watt equals to 100 joule per second. So energy of 1 photon would be equals to, students, hc by lambda. The formula applied is hc by lambda. C given here, speed of light, h is 6.626 into 10 raised to power minus 34 joule second. So h into c by lambda given 400 into 10 raised to power minus 9 meter. You calculated energy of 1 photon, isn't it? So the total energy given over here is 100 joule per second. If you divide the total energy into all the photons, you will be able to calculate number of photons emitted. So number of photons emitted equals to 100 joule by 4.969 into 10 raised to power minus 19 joule. It comes out to be 2.012 into 10 raised to power 20 per second. Now coming to problem 2.8, students. When electromagnetic radiation of wavelength 300 nanometer falls on the surface of sodium, electrons are emitted with a kinetic energy of 1.68 into 10 raised to power 5 joule per mole. What is the minimum energy needed to remove an electron from sodium? What is the maximum wavelength that will cause a photoelectron to be emitted? Students, the energy E of 300 nanometer of a 300 nanometer photon is given by h nu equals to hc by lambda. So the value of h into value of c by lambda, it comes out to be 6.626 into 10 raised to power minus 19 joule. So this is the energy of 300 nanometer photon. The energy of 1 mole of photon would be, students, this 6.626 into 10 raised to power minus 19 joule will be multiplied by Avogadro number, that is 6.022 into 10 raised to power 23 per mole, comes out to be 3.99 into 10 raised to power 5 joule per mole. So the minimum energy needed to remove a mole of electrons from sodium would be for 1 mole of electron, isn't it, minus 1.68. You will get 2.31 into 10 raised to power